So the class for ITS 365 would run Mondays and Wednesdays, you know, from noon, from 12 to, 2 o'clock. So that segment there. So it'll be, you know, a typical class, you know, lecture and lab type of thing. Now, I see some students here that I'm not sure I saw before. So let me just really quickly take a look at. I just want to see if there's any new students that I hadn't seen in the roster before. Let's see. So, okay. So I'm not really doing roll call, but I see there's. Okay, so a couple of students out of the class, it seems.
Jacob Warbro, he told me that he's at work right now and his boss is talking to him, so he's gonna be a little late.
Oh, okay. All right. So that's good. So I just, you know, like I said, usually because there aren't that many. I think there's 1, 2, 3, 4, 5, 6 students currently. So it's a low enrollment. So I have to, you know, figure out the class will run for sure. It's just the code will either be 365 or it'll be an independent study, and I'll have to figure out, you know, what we do about Brightspace. That's why I haven't really filled up Brightspace that much, because I didn't want to have to move it somewhere else. All right, so I think I have a clear picture now of everyone in the section here. So there's 4 now. I think someone was possibly in the wrong class. All right, so anyway, so I think we can get started then with, you know, officially with the course. So I'm currently recording. As you know, I will be recording the videos and posting them on YouTube. And then, you know, we'll go from there. All right, so let's get started then. So what I'm going to do today is what I usually do with classes. I'm just going to I'm going to kind of, you know, give you all the administrative things, the syllabus, you know, where everything is, all the resources. And then after that, I'll kind of motivate what the class is about, just to make sure you kind of understand what this course will be about. And then that's it. And then you can ask any questions at any time if you have any questions. All right, so let me share. First thing I'll share is this Brightspace. So let me go over here. And, you know, although it was a short break, I think I've forgotten how to use everything here. So just give me a second. So I'm going to share screen. All right, so you should now be seeing Brightspace. And I saw that there's a lot of things here on, but it's really the 365.001. That's the one that I'll be using, at least for now. All right, so here is the basic message. This provides a lot of information in the announcement. So you can see here, you know, welcome to ITS 365. As you know, given the current pandemic situation, the course, every course, in fact, at PNW is running this way. So we'll be using Zoom. Okay. So I will be using Zoom. The lectures and labs will be held at the designated time via Zoom, which I mentioned is from 12 to 2 in that segment, Mondays and Wednesdays. For some of I'm a person whose name I don't recognize, so most of you've taken classes with me before, but I'll go over this again. I usually use Brightspace, and then I have my own website, so where I like to keep things. So you'll have to use both resources during the class. So if I click on this, you can see I've created a website for this. I modified this yesterday, but it might still have a few issues. But anyway, this is the calendar. I'm pretty sure. Well, actually, the green should be on the Mondays and Wednesdays. All right, so I'll have to change that. But basically, this is the calendar. I haven't really filled it up yet. I'll do that as I go along during the semester. And you can expect that all the videos will appear here. So I'll create links every time we have a lecture or a lab and there's a video associated with it. I'll provide the link here. It'll take you to YouTube. So it's just a nice way of keeping all the videos organized, in the calendar. So you can see that.
We don't see your website if that's what we're supposed to see.
Oh, I'm sorry. Okay, hold on. Yeah, sorry about that. All right, there's now you should see it. So you can see I just clicked on it, just as ITS 365. This is just, it's a very quick way that I can provide information for you guys other than Brightspace. So as I said, this is the calendar. I still need to modify it. Obviously, the class meets Mondays and Wednesdays. And then the dates are there, but I have to fill in all the links for everything. But these are some tentative dates that you can keep in mind for the semester. As you know, this is the channels where I put all the videos. I usually put videos for all my classes, so you'll have to look up things by number, but that's why you also have the calendar. GitHub, obviously, we'll be using that a lot. Whenever I provide code to you guys, I will always just put it on GitHub and you can retrieve it from there. I need to update some things related to the environment. I have requested for Scholar, which for those of you that have taken another class with me, we've used Scholar before and it works well enough. And it's just a cloud, basically, a Purdue cloud for Linux computers. So either GPU or CPU. We'll be using Linux or Windows. You can use either one. It doesn't really make. I mean, you can do pretty much everything on either one. But the Scholar, I think they're all Linux. Some of the core, some of you took 520 last semester, so you know that a few of these things, like we'll be using Anaconda and that type of environment, and I'll talk about it, when it's appropriate. But just be aware of that. There's a few tools. I've also added the books for this course. If you notice, there's 2 books. You can see them here, the textbook. So data mining, practical machine learning, tools and techniques. I like that book. It's a really nice, very simple book. Doesn't have much programming in it. It's not a programming per se book. And then there's machine learning, which again, if you took 520, you already have this book. Just get the latest edition. That book covers pretty much everything. I teach currently 3 courses in machine learning, deep learning and everything. And that book pretty much chapters, I use chapters from that book for all my classes. So as you might imagine, this class, which is what I need to motivate a little bit more today, will cover the basic chapters, the very first chapters. So definitely, if you have that book, or if you don't have it, if you're just gonna get one book, get this one. I think it's called actually Python Machine Learning by Sebastian Rashka. I'm sure I have it correct in the syllabus, but just get the latest edition. All right, so that's the website, and I'll be coming back to this a lot, but let's go back to the syllabus, okay? So, you know, obviously you all have computers, you're connected to the internet. But if you want to use VMs, which I don't recommend, here's a link to a VM. I also have another, I can have another VM on my server. You can always download that one as well. However, I would recommend pretty much that you get Anaconda for Windows or Linux, or, you know, when hopefully we'll get Scholar, and then you can also use that as well. Lectures, I'll create videos and post them on YouTube, as I said, and then the videos will be linked on the calendar website that I just showed. I hope I'm sharing this. Yeah, I'm not sharing it. I'm sorry. All right, now I'm sharing. So the videos will be linked on the calendar. Labs, we will use VMs to complete the labs, or, you know, as I said, Scholar, or you can use Anaconda on Windows, Linux, etc. All right. The assignments will be linked on Brightspace, however. All right. So as far as homework, and this, please, you know, follow this as much as possible. Use Brightspace. So I will post all assignments, all information on Brightspace, and I'll talk about that in a second. And then also, please only submit via Brightspace. I usually give you plenty of time to complete assignments. You know, don't send me homework via email. That's, you know, that's usually, you've seen that I don't grade. If you send me homework via email, I grade that at the very end of the semester if I have time. So please, you know, I usually try to do most of it, but I ask you, please don't do that. Instead, you know, try to submit on time, or ask for an extension before the Brightspace closes. Office hours, you can email me, you know, and we can talk about, you know, your questions. We can also set up, designate a period during the week, you know, like you know, connect online on Zoom. And of course, I have office hours. And so I'll talk about that in a sec. Exams will be done, you know, I don't know when we'll be back. I'm assuming in August we'll be back on campus. But for now, unfortunately, we have to do these exams online, or they'll be take-homes. The great thing about this course is that it's a very applied course. And so I can always just give you a take-home assignment, which is good. Meeting place is Zoom. Meeting time and date, you know, lectures and labs, Monday and Wednesday, 12 to 2. And then office hours, there you go. It's usually Tuesdays and Thursdays, 2 to 4 p.m. And otherwise, you know, by appointment, you know, or if that time doesn't work for you, we can find another time. Usually Fridays are the, you know, what works best for me, but we can try to schedule something. Obviously, you found this information because you connected to the Zoom link. There's the information on all of that, okay? All right, so now let's go ahead and move to the content, and then that way I can talk about the syllabus. I believe I've populated this already. Yeah, all right, so you can see here, I usually just, everything that I post on Brightspace will be posted on here, okay? I use this idea of modules. So basically, there's a module and all slides, lectures, labs are in that module. So sometimes something will have a lot of material, sometimes something will not have a lot of material. However, what's great about this course, as I said, is that it goes really well with that book that I mentioned. I will provide a lot of additional materials, but in essence, I'm following that textbook, which is, you know, I think is a pretty great textbook, and of course, I'll explain a lot of the things. All right, so let's see. All right, so as you can see, this is the structure. Admin, you know, that's usually where I put the syllabus. You can see the syllabus is there. I'll talk about the syllabus in a second. This info is just the same information in the announcement. I just wanted to, sometimes I've noticed students forget about announcements, and they're always looking for the information here. So this semester, I also put it here. Okay. And then, as I said, I'll talk about the syllabus in a second. These are the topics for the semester. So this class is actually, as I said, I should kind of give you some context, right? So this course is a brand new course. It's running for the first time today, now this semester. It is part of a new minor that we've designed called Applied Data Science. So we have, and then we have some machine learning courses, also AI courses in the graduate side. So a lot of our students, do their undergrad, do 4+1, or do the masters as well. So basically, you probably looked at the curriculum already. It starts with, well, there's a few courses that are kind of background, but you guys already take them for CIT anyway. You take like ITS 140, which is now a Python-based course. There's a couple of other programming courses like 240, 245, I think. So by the time you get to these classes, you've had a lot of that programming background. There's a statistics course, 300 level, which you will either take probably this year or next, or you've already taken it. So those are sort of background courses. And then I think the stats course is actually part of the minor, but you've already taken it. I don't know the number, but I know it's part of one of those. All CIT students have to take that course. All right, and then that leaves the other 4 courses of the minor, which are ITS 265, which is a course Professor Tae-Hoon Kim is actually teaching this semester, I believe. That's the Introduction to AI class. So basically, one thing I should say, let me switch to the whiteboard for this. Okay, so switch to the whiteboard. You should now be seeing the whiteboard. So basically, this field, this is the concentration in applied data science. Okay, and then within that, so basically, there's a lot of names for this currently, but all of us have heard of artificial intelligence, AI, right? We've all heard about it. Used to be almost like science fiction. Now it's very real. So within that, there's machine learning. And then within that, there's specific fields like something called deep learning, right? And then where does data science come in? Well, data science is because there's also, like business, right? Business analytics, let's say, right? And so data science is kind of, something that covers both, okay? It's something that it kind of covers, it's like data science covers parts of AI, parts of machine learning, parts of deep learning, but also other aspects of like business analytics, just, and what is business analytics? How would I put this? Well, let's say you grab an Excel spreadsheet, you collect information here and there, and then you do some analysis, right? Some marketing analysis, accounting analysis, whatever it is. So that's what data science really is. And so going back to the idea then, Professor Kim in his 265 is going to cover some of the broader topics of AI, okay? Like, how people study chess, and different things like that, which doesn't necessarily mean that you're using machine learning, right? So because machine learning implies that the machine is actually learning. It learns from the data. Whereas with AI, you can have something called an expert system, where the expert system actually just, you have a whole bunch of rules, like in chess. Chess is like a decision tree, a tree basically, a hierarchical tree, binary tree. And it's made up of a whole bunch of rules. So if somebody makes this move or that move, then I'm going to move in that direction. If they move, you know. And so it doesn't necessarily mean that the machine is learning on its own. Instead, you're just kind of programming. So if you want to think of it like a lot of if statements, right, that you kind of craft by yourself. These are called, you know, the technical term is heuristics. All right, so that's why, you know, we have Intro to AI. So the Intro to AI course, 265, will cover that. It'll also cover like the background. So a lot of the background that you need for this course will be covered in 265, you know, such as optimization, you know, matrices, vectors, and that just is associated with some libraries called NumPy and Matplotlib. So I'll let him talk about all of that, but basically just be aware of that. So that's the 265 course. This course, the 365, is machine learning, okay? So the 365 is gonna be the machine learning. And actually, we have another course, 520, which is called Applied Machine Learning. And then we have this one, 365, which is also called Applied Machine Learning. We are going to change, tweak the name a little bit. And actually I'm going to be calling this class something like Machine Learning Foundations, okay? Foundations. So this course will be about those foundations, okay? So, you know, you guys are juniors basically. You know, programming is very fresh in your minds right now because you're somewhere between having taken data structures or about to take data structures. So you are at that level. And so therefore, this is a perfect place to introduce a lot of the foundations, which it's not a lot of programming and it's not hard by any means, but it'll provide the foundations. Plus, we're going to cover just a lot of topics that we don't have time to cover in the other courses. 520 rightfully is called applied because it's more about solving problems, you know, dealing with data sets and things like that. This one, although it'll cover that as well, it's a little bit more focused on the foundations, okay? You know, so, but you'll see that. At the end of the day, in machine learning, there's a single pipeline. If you want to, you know, I usually call it a pipeline, right? So it's basically a sequence of steps that you follow from the beginning of the problem to the end of the problem. All classes, you know, 365, 520, 265, 530, all classes will have the same pipeline. So there's a few topics that we always have to be aware of, like the vector space model, performance metrics, etc. So, you know, I'll talk a little bit about those fundamental pieces of the pipeline, but just be aware that the difference between 520 and 365 is that 520 is the grad level class is more focused on the data sets and solving the problems. This one is a little bit more focused on, let's say, the algorithms of machine learning and the foundations. All right, and then at the end of the day, deep learning is a huge topic. I'm not going to cover it that much in this course. Instead, actually, in this course, I'm going to cover neural networks, you know, the foundations of deep learning. All right, so I'll cover neural networks, you know, backpropagation, feed-forward algorithms, chain rule, and all those fundamental pieces that will make your understanding of deep learning a lot easier. As some of you know, we have a course, 530, which is a deep learning course, which goes into all the different algorithms. In this class, though, probably just for completion, I'll throw in Keras at the end, just to kind of show you. I mean, Keras is very easy to pick up, and it allows you to solve problems. So, but as I said, just for completion, I'll throw that. The focus is more on the foundations of everything, which that way you'll have a solid understanding of machine learning and deep learning. Any questions so far, guys? Okay. All right, and then after that, so I've mentioned in our concentration, you know, 265, 365, and then the other two are 400 level classes, which I believe actually, for those of you doing a master's, I think you're allowed either one or two 400 level. You have to confirm this with your advisor or the chair of the department, but I believe for a master's, which is 10 courses, I think, depending on whether you do thesis or not, I think you're allowed two 400 level courses as electives. And so actually we have two here, which are, I can't remember the numbers, 470, I think. And I don't remember, 465 maybe. All right, which are very important classes. 470 will cover high performance for machine learning. So if you've ever heard of the buzzwords like Hadoop and Spark, you know, that kind of thing. So Professor Kim covers that course. And then also there's a visualization class, 465, which will focus, I believe it uses, among many tools, something called Tableau. So just popular tools for visualization. Although you probably know if you took 520, or you'll see in 265, even in this course, 365, we'll always be using a library called Matplotlib. And so Matplotlib is a great library for visualization as well. So visualization is just part of the whole, again, it's part of that pipeline that will appear in every single course, except that 465 just has a specific focus on the visualization aspect, which should be very, very useful. If you think, when you hear the terms applied data science, or you think of the term data mining or big data, or, you know, it's about looking in the data to try to find insights, right? To try to find information. All right, so anyway, so that's the concentration. And so our course this semester is, as I said, 365. Basically, I'm hoping that by the end of the semester, we will have changed the name, hopefully. I don't know, we'll start this stuff moves slow. But, you know, since we just started this program, you know, we kind of named things. That was my mistake. I didn't really think of a name. But I do want it to be something like machine learning foundations, something along those lines. So that way, you know, 520 and 530, you have the background basically. So we don't have to, you know, that has always been the hope of our minor, right? That when you get to 520, 530, when you get to 470, 465, we wanted you to have this background that you should get with your programming courses, your stats course, and these two courses, okay? You know, I cannot stress how important they are. I cannot stress how important they are. You know, that they do have a little bit of math, but, you know, it's applied math, and you'll love it. I mean, you'll learn to appreciate how useful it is, okay? And just stick with it. It's not as hard as you would think. All right, and, you know, I'm teaching this for the first semester, so certainly give me feedback, you know, if you're ever struggling or anything like that. But as I said, I will be following that book, so we have that resource as well. All right, so that gives you a little bit of background kind of on the name of the course. So let's switch back to Brightspace. All right, so here in Brightspace, as you can see, before I start talking about the individual topics, let's just get into the syllabus. I'm sure you want to cover the syllabus, so you should now be seeing the syllabus here. All right. So as you can see, I've changed the name here in the syllabus, Machine Learning Foundations. So this is spring 2021. So I'm Professor Calix. There's my office number, office hours, my office, email. All right. So the course description, this course provides a basic introduction to the machine learning pipeline, right? So what that means is just a sequence of steps when you have a problem in machine learning and related concepts. topics covered include machine learning uses and applications, data set requirements, data pre-processing, where in this course, you know, we'll not spend so much time on that, on like dealing with data sets. We'll basically start with data sets already, and then the focus is more on what follows. Data annotation and validation, so I'll talk a little bit about that. Corpus statistics, so that's something that's, you know, we need to cover. Data representation formats, features and feature representation and extraction. So that's something that any machine learning course needs to cover. Features, the vector space model. Then as it relates to features in this course, we'll spend some time talking about feature ranking and feature compression and basically the focus of the course is the algorithm. So we'll talk about something called the chi-square algorithm, information gain, and something called singular value decomposition. So those are feature ranking or dimensionality reduction techniques. We'll talk about traditional machine learning algorithms. So in this course, actually, while in other classes like 520 and 530, I don't usually spend too much time on traditional machine learning algorithms, I will do that in this course. So because this is a foundations course, you know, it's important that you learn, you know, how does KNN work? How does naive Bayes work, right? So we'll go into, so in this course, we'll go into the algorithms a lot more than just using them through libraries. So the traditional machine learning algorithms, which, you know, they'll become, you know, I say, you know, when I talk about the pipeline, you can think of the pipeline as a whole bunch of little boxes that follow in sequence. So one box can be replaced by another box, all right? And so, you know, I can replace the box of the machine learning algorithm with one of the many traditional machine learning algorithms, or I can replace it with a deep learning algorithm, you know, et cetera. So they're interchangeable. And we'll learn about that. Machine learning algorithms and programming. So that's actually one of the main emphasis of the course, is that in this course 365, everything we use, every technique, we will look at the how it works. Not just, you know, how to use it, but, you know, how does it actually work? How do you code some of the simpler algorithms, obviously, but we will look at the foundations of them. Machine learning evaluation methods, obviously, you know, you can't build a model in machine learning without evaluating, right? So that's the performance metrics that you use throughout. So you'll probably see these performance metrics in every single course that you take in this track. We'll talk about the t-statistic and something called statistical significance. That's part of the evaluation methods. We'll cover, as I said, you know, neural networks and a little bit of deep learning just for completion, kind of so that you're aware of everything. But really, as I said, the focus is more on the background leading up to neural nets and deep neural nets. We'll talk about big data. You know, you got to talk about that. And one of the reasons why we have Scholar is that we can actually use that tool for that. And then we'll talk about reinforcement learning. So in this course, you know, I kind of decided that I usually like to talk about reinforcement learning. So I just, in every class I teach where I do reinforcement learning, I just do a different problem. So in this one, we'll do a problem called the Taxicab Problem, which is about using a reinforcement learning algorithm to teach, you know, we create a simple game, a 2D game, where a taxi cab has to pick up a passenger and then take that passenger to one of 4 locations. Right? So the algorithm actually has to learn how to do that by itself in the most efficient manner. And so, you know, it's a more complex algorithm, but we will take a look at it. Should be fun. We'll talk about, you know, the basic things, supervised and unsupervised learning, statistical significance, and something else called, when I say, and other special topics, I will cover sequence mining. I had a student that had asked me some questions about sequence mining, but I don't see him here today. In any case, sequence mining is for that type of problem when you're trying to forecast in something in the future. For instance, you're trying to forecast, you know, what is the consumption per day next week? You know, on Monday, on Tuesday, on Wednesday, on Thursday, on Friday. Given that you have some information like the weather, is it going to be hot or cold? You know, is it going to snow? Is it going to be sunny? You know, that kind of thing. So you look at information in a sequence, and that's, you know, that's called sequence machine learning or sequence data mining. And we'll study the algorithm for that, which is called the hidden Markov model. And there's a very famous algorithm associated with the hidden Markov model called the Viterbi algorithm. So we'll study that as well. Should be a lot of fun. And as it turns out, the Viterbi algorithm is used in a lot of different fields, like in natural language processing. Okay. I won't have much of an emphasis, since I just mentioned natural language processing, I won't have that much of an emphasis on NLP this semester. We will not be, you know, dealing with like text or tweets. You know, that's, if you're interested in that kind of thing, like social media, I definitely recommend you take the 520 class if you haven't done so already. But in this course, the focus will not be so much on dealing with data and converting it to a data set for machine learning. Instead, the focus is more just on already having the data sets and then learning all the foundations of the machine learning. All right, are there any questions so far, guys? Any questions?
Nope.
No? Okay. All right, so. So, all right, so here are some of the, let me just do something for, give me a sec here. All right, I'm back. I should be seeing the syllabus again. All right, so course objectives and learning outcomes. As I said, this is kind of a evolving thing. Okay, it's, you know, as we've been kind of placing the topics. Okay, so I might be missing some topics here. It's possible. But these are some of the main objectives. So understanding the basic machine learning pipeline. Obviously, I'll start with that. I'm going to start assuming that you don't know anything about machine learning, right? So I'll start there, kind of motivate that this week and next week. Okay, so that's the first part. Then understanding how to extract data for machine learning. And there, you know, really the focus will not be on the data extraction, but just understanding what the features should be. I don't want to do much feature engineering, if you will, in this course, but we definitely want to understand about data sets, understanding machine learning in the context of big data. So that just means that a lot of the data sets that we will use this semester are going to be pretty small. But really, if you work in a company, imagine if you're trying to predict something about elections, right? You're going to look at a lot of data out there in social media and Instagram, Facebook, Twitter, you know, what people are saying. Excuse me. So that's a lot of information. That's a lot of data. I mean, gigabytes, right, of data. Could be images, could be, you know, all kinds of things. And so that's what big data basically means. It's just taking a lot of data and dealing with it. You know, and that's more a focus of my 520 course. But here, you know, we'll still talk about the fact that when you really have a large data set and your computer just dies, you know, because it just doesn't have enough RAM or whatever, then what do you do? Okay, so that will be kind of the information, and that's why we have the 470 course. So Professor Kim's high performance class, Plus, in this class, I'll talk about GPUs and how they can also help with that. Understanding data pre-processing techniques, understanding features and feature extraction techniques, in particular feature ranking and feature dimensionality reduction. Understanding the vector space model, that's a key concept that you must master in any machine learning course. And then understanding traditional machine learning methods. So I'll mention, we'll go in this course, and talk about individual machine, not all of them, of course, because there are easily 20 to 30 very popular algorithms, and then there's others that aren't that popular, right? So you can always just create an algorithm. I myself created an algorithm called the deep granulator. Basically, I just took something called a granulator and I added deep learning and I created this thing. And it's just an algorithm. It just it does something in particular. It's not a machine learning algorithm. It's a feature ranking type of an algorithm selection. But there are many, right? So imagine if I created one, how many people have created one, right? So there's hundreds, thousands. So we'll just talk about the top 20, or not the top 20, but of the top 20, 30, we'll look at some of the algorithms for traditional machine learning. Obviously, the neural net, the perceptron that leads to the neural net, which leads to the multi-layer perceptron, which leads to deep learning algorithms. So we'll talk about that. That's actually the second half of the semester. We'll spend a lot of time on that. And then we'll talk about some of the other algorithms here in the beginning of the semester that deal with features, such as the granulator, such as the chi-square and information gain. We'll talk about singular value decomposition and other things like that. All right. So that's traditional machine learning methods, basic understanding of deep learning, an intro to reinforcement learning. As I said, usually reinforcement learning could be a course in itself. So what I do, because I don't always end up having that much time with reinforcement learning, is we'll just cover a problem. That's the best way to understand reinforcement learning. Reinforcement learning is its own thing. So we can actually just code reinforcement learning from scratch. We'll probably do that. And we'll analyze, as I said, the Taxicab problem, which is a little bit more complex. Unsupervised learning, we'll cover that. In 520, I do cover it from the point of view of just using a library. Here, I'll be covering actually on the point of view of the k-means algorithm. So understanding how it works, understanding even how you could code it yourself. What's great about k-means is it's very similar to k-and-n. So once you understand k-and-n, you kind of understand k-means, and you can the algorithms have similarities. Understanding of common machine learning evaluation methods. Obviously, that's a very important thing that I cover in every course. This course, though, will be a little bit more thorough. We'll go into something called the t-test, which hopefully if you took your statistics course already, don't worry if you haven't, but if you've done so already, you've probably seen that, you're aware of something called the p-value. And so we'll talk, and you'll see it's nothing very complex. And we'll be helped out with libraries sometimes as well. All right. And then the other objectives: collaborate with team members to resolve machine learning problems. So this is a small class, so we'll do a group project, groups of 2 probably at some point. And it's small enough that you guys can work together. Conduct some type of independent research. So the project will be, it's not going to be worth that much, but it'll be some kind of project. And then, as I said, I'm missing here sequence mining. I need to update that, which, as I said, covering the hidden Markov model, getting a sense of that. It's very interesting. I've had at least 2 sets of students that have wanted to do problems that require sequence mining, which is interesting, which tells you something about that type of problem, right? So in the past, I know I've had a couple of students or groups that have had that. So that's certainly a topic that I want to cover in this course. All right. So the prereqs for this class, as I said, at least a programming course. So usually, you know, any CS or CIS or our own ITS 140, which is now a Python-based course. It's actually a pretty good course. I taught it last semester. If you for whatever reason feel, you know, like you want to brush up on your Python, you know, that whole course that I taught last semester is on YouTube, right? So you can go to my, so let me switch over to the website. So if you go to the website and you click on courses, you can see here this one, Intro to Computer Algorithms. The entire course is there, right? All the videos and everything. So if you find yourself, you can look up by topic even. So if you have any, you know, any topic that you kind of want to brush up on, you can take a look at those. Certainly there's a lot of information on YouTube, etc. But we will be using Python almost exclusively, if not exclusively on this course. We're doing a lot of things. Usually, since we're kind of starting this in the future, usually students will take 265 first, then 365. 265 would have given them a lot of the background in NumPy and pandas and everything, so that those skills would make a lot of the programming even more easy. So I'll take that into consideration this semester. I'll try to keep things simple as possible and keep that in mind. All right, so so this is 3 credit hour class. The textbook, as I said, is you can go ahead and purchase this book if you'd like, if you don't have it already. I highly recommend it. It's a really great book. Just go on Amazon, look at the reviews. You'll see it's a really great book. It's called Python Machine Learning by Sebastian Rashka and Vahid Mirjali. And just get the latest edition. I think they're up to the 3rd edition. And you can see there from that book, we'll cover, I actually have it here, I think. So we'll cover, you know, chapters in it, you know, some of the math foundations of it. You know, we'll probably cover a little bit of chapter 4, which is, you know, data sets, pre-processing. We'll cover chapter 12, which is implementing a multi-layer artificial neural network from scratch. We'll cover ensemble learning, combining different models. We'll cover that's chapter 7, I think. We'll cover, you know, the first chapters, obviously, chapters 1 and 2, the optimization chapter, regularization, and so on, right? So we'll cover a lot of it. So certainly get the book. I'll be using that, you know, throughout. All right. The other book, Data Mining, Practical Machine Learning, Tools and Techniques. This is also a great book. This is a programming book here, this one. And the data mining book is not really a programming book. There's a lot of tools that we will use this semester. And you know, just like in any other class, I will use the tools that I think are most appropriate to convey a topic. So usually it'll just be plain Python and maybe a couple of libraries. But every now and then, there are things where something using a program called Weka just makes sense, okay? Just drives the point really well. It's a GUI interface. And the book for the WEC program is this one by Witten and Frank. So I don't, you know, I'm sure you can find a lot of information online, but if you feel like, I'm sure you can purchase it, even maybe not the latest edition, an older edition that's cheaper, should be the same, or it should be pretty good. So as I said, you're not required to buy any of these books really, but I would recommend getting this one, the Sebastian Raschke book. It is pretty good. I think, you know what, I think what happened was I updated this list of topics that you're seeing here, but not the course objectives. So that's probably what happened, because I can see here, these are the topics that I remember. You can see here now I have the topics like dimensionality reduction and feature ranking. You can see that's in there now. Theoretical foundation of machine learning. You can see that I've talked a little bit about Python and sklearn. Perceptrons and neural networks, optimization, backpropagation, and the chain rule. So you can see that. But anyway, it doesn't really matter. All right, course grade. So you can see here, the course will have one exam, a midterm, basically, and a final exam. So 20% and 20%. The term project will be worth 20%. And then you'll have assignments, which will be about 40% of the grade. You probably won't have an assignment a week because, you know, the course just doesn't lend itself for that. So, you know, sometimes we have to spend, especially because this is a foundations class, so we have to spend quite a bit of time on a topic. This is a depth, not a breadth of topics. So if you think about it, you know, there will be some basic topics, but I'm not going to cover every single thing. But there are some general ideas. The focus on the algorithms, feature extraction, and then the different algorithms for different types of problems. Okay, so that should add up to 100% of your grade. Okay, you can read the rest, I'm sure. The only thing that's key of all of these is with assignments. Please, I guess I missed this part. We're not using Blackboard anymore, but you know what I mean. Homework may only be submitted on Blackboard. Please submit only on Brightspace, okay? You have no idea, my email inbox just, especially right now with online, it just gets unmanageable, all right? If I get all these emails of homework, so please try to submit your homework on time. Use the sessions when we have class, right? If you feel like we have a homework due tonight or whatever, and you guys feel that you need more time, certainly bring that up here, because that way I can ask everyone if everyone wants an extension and just extend it. That's usually the best way, and that way you all submit on Brightspace. Okay. And then here's the course outline. You know, as you know, I'm sort of, this is kind of the way that I plan to follow it, but it might change a little bit. So as you can see here, introduction to machine learning, that's what I'm doing this week. Features and the vector space model, just make sure this concept is clear in everyone's mind. Performance metrics, obviously these are things, this is the basic pipeline basically, right? So the pipeline, features in the vector space model, and then performance metrics. Right, and so cover this basic information. Then after that, we'll get into the feature techniques, feature ranking, chi-square information gain, dimensionality reduction, singular value decomposition. I love this topic. Singular value decomposition to me is fascinating, and so we'll take a look at that. And then we'll look at, and these are algorithms. So at this point, when you start chi-square or information gain, all of these, we basically started. These three, I would say, are like pipeline and just like understanding the different components. But once we get into week 4, I guess, we start getting into the algorithms. Then the very first thing we will get to is something called recommender systems. Recommender systems go really well here because they basically feed from dimensionality reduction and singular value decomposition. So recommender, anyone know what a recommender system would be? What do you guys think? How would you use a recommender system?
Is that like advertisements?
Can you turn up your volume a little?
Is that like advertisements?
What do you mean?
Like if you search up something on Amazon, like I don't know, like baby powder, so then it would recommend like I don't know diapers too or something.
Exactly, exactly. That's a recommender system, exactly. And we'll learn exactly how that works. Okay, so and you'll see the beauty of it, right? That you can build, as you said, you know, a site, and based on people's preferences, you know, they can then, and it's not something that people have to say, I like this, I like that. It's just based on, well, they might, but based on a little bit of information that you have, the algorithm figures out the rest, right? And so that will be the very first application that we will talk about this semester, recommender systems and how you could implement one. And you'll see it's actually pretty straightforward. It's not very complex, but yes, very good. After recommender systems, we'll start with the traditional machine learning algorithms, you know, KNN. All right, so I'm not, it's definitely going to be one of your homework assignments where I'm going to ask you, for instance, to code the KNN algorithm. And you'll see it's actually pretty straightforward. You know, and then you can use certain tools to help you out along the way. Usually a lot of this, when you have like the NumPy background, that helps out a lot. So I'll either provide a little bit of a crash course in NumPy. I need to consult with Professor Kim. So one question I'll ask you, are any of you taking 265 as well? Are any of you taking 265, or are you just taking 365?
I'm just taking this class.
Okay. All right. So yeah, so there's some of you that aren't taking the 265 course, so then I'll probably provide a little bit of background in those topics. But the traditional machine learning algorithms that we will cover are the basic ones, that everyone should know, KNN, naive Bayes. So we'll go into the background of them, decision trees, and we'll cover a little bit of support vector machines. After that, at that point, you know, we'll do a midterm, and then we'll get into neural networks. Now, neural networks, you could say it's part of the traditional. Like I could have said KNN, naive Bayes, decision trees, SVM, comma, neural nets, right? It's just one. I want you to understand that it's just one of them, right? One interchangeable. It's an interchangeable box in that pipeline. However, which neural networks have existed. They started with something called a perceptron back in the 50s at Bell Labs, and the mathematical framework existed for centuries, right? So, but basically neural nets, that is to say one of these traditional ones evolved or is the grandfather or great-grandfather of something today called deep learning. And deep learning is an extremely powerful set of techniques for solving AI problems, right? And so to understand really deep learning in this course, we're going to study neural nets, okay? And really go into the foundations of a neural network, starting with the perceptron and how that works, and then talking about some of the additional algorithms that give us neural nets, like back propagation and something called the chain rule, feed-forward networks, and then how that leads into deep learning. For completion, though, I don't just want to give you the background and you know the theoretical framework, but then you go out there and you really still don't know how to solve a problem. So that's why I think I'm hoping that after this, I'll cover Keras and basic deep neural nets for just supervised learning. So Keras is a way of implementing deep nets, which makes it very easy and straightforward. So the focus is, as you might imagine, it's not really Keras. It's really about the foundations and the background of neural nets. But for completion, I do want you to be able to. So we'll do a homework, no doubt, with a whole bunch of data sets where you apply this. Then after that, I'll spend some time on reinforcement learning. As I said, I usually like to cover at least one of these. So we'll cover one problem, the Taxicab problem. And then after that, I really meant to say special topics here. We'll cover hidden Markov models, which is sequence mining, sequence data mining. And that's somewhere in here I'll throw we'll talk about the differences between all of these. So that's really something, you know, probably the next thing I'll talk about is what all of these things are, you know, like supervised, unsupervised, etc. So that's the tentative schedule. As you can see, focus on the techniques, understanding how they work this time around. Features first, starting with recommender systems, traditional machine learning, then neural nets, really the foundations of them. And then after that, covering hidden Markov models, reinforcement learning, and k-means, basically. So that's really all the algorithms out there for machine learning, okay? All right, so, or not all of them, I should say, but a lot of them. I mean, there's others, like, you know, there's a lot of things. Like, for instance, if here in dimensionality reduction, singular value decomposition is just something that I like, especially because it feeds in really well to recommender systems. But there's another technique out there called principal component analysis. It's just a technique that's a little bit more difficult to understand, I think. So I usually just prefer to cover this one, which does a great job, does the same job actually, and it's just a lot more intuitive. And I just don't think we'd have time for PCA this semester, but we'll see how it goes. All right, so that's the schedule, the tentative schedule. As you know, all the security stuff, make sure you read this. We're not on campus, obviously, but, I'm sure there's some COVID-related things. There's no reason why we need to go to the university this semester. I have been advised that the university is closed, I think. So I'm not sure exactly I don't think there's any labs. However, I put in, as I said, the request for Scholar. So you guys, I'm sure, are familiar with concepts like the cloud. I'm sure you've maybe tried to use AWS at some point. So this is similar to that. It's Purdue's own cloud services, right? So it's called Purdue Scholar. And so I put in a request for that. So hopefully that way you guys can use more powerful computers in the cloud for this course. So we'll talk about that as soon as it's approved. All right. All right, so that's the syllabus. Are there any questions about the syllabus before we continue? Any questions? No questions? All right. All right, so let's now excuse me, go. Oh, so let me go to, so basically everything that I will put related to the course will either be on Brightspace or it'll be on my website. So for instance, I usually don't like loading videos like I know Brightspace has a feature for loading videos, but I really like how YouTube is extremely efficient, right? So YouTube is extremely efficient for managing videos and dealing, it's much faster. So I'll just post them there, just be aware of that. And then I'll link everything to my website, as I said. But usually the course materials will be here. You can see that under content. I've already started to add things here. I realized that I wasn't sure if we were using the independent study or not, and so I didn't want to have to do work twice, right? So I haven't really loaded all the materials yet, but I've added a few. But at least we can look at the topics. So we'll start with machine learning today, just the differences. You know, what is reinforcement learning? What is this? What is that? But you can see here, I kind of have a basic set of courses or of modules, right? So I have the first three are just pipeline. All right, so what is the machine learning pipeline? What are the components? To talk about that, features in the vector space model, performance metrics. Okay. Then after that, I start getting into the algorithms. So you have KNN naive Bayes, dimensionality reduction, singular value decomposition systems. I do have PCA in there. I do have feature ranking and, you know, chi-square, then decision trees, t-tests, and statistical significance. And then we get into the neural net part, which is optimization, regularization, the perceptron and neural nets, backpropagation, the chain rule, feed-forward networks, intro to deep learning, a little bit of Keras. We'll talk about this also in this course, which is the machine learning cloud solution. So I am sure that you've heard that, you know, it's big business, right? And so a lot of these, AWS, I believe also Oracle and Google, they have a lot of solutions online. So what they have is what they have is obviously they have their powerful servers, and then they have device, you know, do you want to create a chatbot? You know, you may not even know what a chatbot is, but you can create one, right? With AWS, they have already pre-trained data. Google Collab, for those of you that have heard of something called like the Jupyter Notebook, Google just always, whatever someone invents, they just invent their own version. So they created Collab. I think, you know, obviously in the future, they want to make money off of this. You'll have to sign up for Pro and pay maybe, I don't know, $5 a month. It's not required in this course, but I'm just saying a lot of these things, remember, are profit driven. But at the same time, they do provide a lot of simplified cookie cutter type of solutions. You know, like I said, you want to create a chatbot. Do you want to create a racer? I think they have that also, like creating a car racer, which basically uses reinforcement learning, right? Or the chatbot would use like NLP types of things, a deep learning. So anyway, we'll cover this. I'll prepare something I've been wanting to do. It'll probably just be, you know, a short week, but we'll go at least to the cloud and look at what's available out there. And I am actually saving it for towards the end of the semester though, so that we've had time to really absorb a lot of these other materials. Then as you can see, Taxicab, I've already added the link to the code, and we'll explore that. Unsupervised, also here, I should have mentioned hidden Markov models. As you can see, I just added. And then this unsupervised should say actually k-means, which is really what I want to focus on. All right, anyway, so that's these are some of the modules that we'll see this semester. All right, so I think that's pretty much it as far as administrative things, the syllabus, just where everything is. Once I have, if hopefully we'll get Scholar, once I have Scholar's information, I will add it to my website here. It'll be under Machine Learning Foundations, of course. So 365, so somewhere in here, I'm still updating this, as you can see, but somewhere on here, probably under useful, I will add information about Scholar and how to connect to it. I think you just use your login, etc. And then we'll start populating these. Today, you'll see I'll add a link. If I still remember how to do that, I'll add the links here. Yeah. All right. So as far as the schedule, as you can see, next Monday is, I think, Martin Luther King Day, so no class. Then spring break, for those of you that want to make a note, although I don't think anyone can travel with what's going on. But, you know, your spring break, the week of March 15th through March 19th. The midterm exam, depending on what you guys want, will be either before or after spring break. You just let me know when we're getting close to that. And then project presentations, as you might imagine, April 27th to 29th. And then finals will be May 3rd through May 7th. All right, so that is the, and as I said, the green here will be, I have to change that to be Mondays and Wednesdays because that's when this class meets. All right, so that's all the administrative things. And now I can start talking about the course itself. But before I do that, are there any questions? All right, no questions then. Okay, so let's get started here. So the first thing I'll talk about today is I'm going to go back to the whiteboard. I'm going to go back to the whiteboard here. And I'll talk about, so I need a new slide. So you should be seeing the whiteboard. So I talked about this, which was basically really to talk about the concentration itself, right? The minor, which is applied data science, which whether you're, as far as I understand, and you should confirm this with Professor Jang, but whether you're a grad student or an undergrad, you know, I think even if you've already graduated, you can get a minor here at PNW. And so basically, if you're a grad student, it would still show in your transcript as minor in applied data science, and also obviously as an undergrad, that would definitely be the case. All right, so I've talked about that. I've talked about the course, you know, the name change, machine learning foundations, and I kind of gave you the big picture, right? So, you know, we won't get to cover chess in this class. That's a really fun topic, but I'm sure Professor Kim will cover that, given that it's been studied. Chess is one of the most studied games in history. And for AI, right? So, but basically here we are covering just, you know, what's in this circle, the machine learning foundations for 365. Okay, so within that, so machine learning then. So now we're kind of within that context of machine learning. And now we want to divide. We usually categorize things, you know, whenever we have a problem, right? We break it up into pieces. So how can machine learning be divided? So it can be divided into several systems. Usually people divide it into something called supervised learning. Supervised learning, something called unsupervised learning, reinforcement learning, right? And those are the three. I don't know why I created three. All right. So those are the three areas, right? Usually people spend the majority of the time on supervised learning, okay? And we will do that certainly in this class. For unsupervised learning, I will really just spend my time on the k-means algorithm. We'll talk about that. Okay, and then as I said, with reinforcement learning, we'll just take a look at how that works. However, there is, let's say, within these three, there are other divisions, right? There are other. So here we have, for instance, here within supervised learning, then we're going to have all the traditional algorithms like KNN, naive Bayes, but also we're going to have neural networks, right? Neural nets. Also, hidden Markov models in a way go in here because they are based on data that you have, right? So you can sort of say it's supervised. So hidden Markov models, which is sequential, sequence mining, and of course, deep learning. Right? So those are some of the topics that go in there. Within reinforcement learning, there are some algorithms. The main algorithm that we will study is Q-learning. However, you know, given that this is a foundations course, we might go into a little bit more of reinforcement learning. Okay. So basically, that's the first thing that, you know, I kind of mentioned in this course today, right? So machine learning, which we've already seen as part of this bigger context, can be divided into these three areas. Out of these three areas, it's divided. Now, there's a reason why we divide it, right? And the reason why it's divided into supervised, unsupervised, or reinforcement learning, it has mainly to do with data. You know, what data do we have? So when we have data, so for all of these, they all have data, but supervised learning just means that I have the following situation. I have some information here associated with other information over here. So I have this data associated with that data. Call it A and B, right? And so whatever, this can be many values. This is usually 1 or 2 values, or 1. So what are we doing when in machine learning? We are basically learning to associate. You have an algorithm, some algorithm here. Let's say, you know, an algorithm. And what does the algorithm do? Or the algorithm comes in, you imagine this is like a magnifying glass, right? So it's a magnifying glass, and it starts to look at the data in detail, starts to explore it, and then it starts to create associations. Okay, so it starts to make associations. So what do you mean by that? Well, it means that, for instance, whenever it sees, let's say, just for an example, I see green. I see green. I see blue. So whenever I see green, and that just means that this information here represents something about greenness, right? And the like. So whenever I see green, I actually see a tree. Whenever I see green, I see a bush. Whenever I see blue, what do I see? I see the sky. Whenever I see blue, I see what? The ocean. Do you see that? So that's what supervised learning means. It means that something, the algorithm learns how to associate the characteristics of A, called the features, with the class, with the information of B, which is usually referred to as the labels or the classes. Okay? And that's all that a supervised learning algorithm learns how to do. Okay? It learns how to create a model of that association. So that's why in this course, you know, we will explore KNN. How does KNN learn that association? Naive Bayes. How does naive Bayes learn that association? Neural networks. How do neural networks learn that association? Do you guys see that? That's basically the idea. It's nothing more than that simple idea. I mean, I'm sure if I gave you guys that homework assignment, you would do it. Okay? I don't want you to create a complex algorithm. Just create the simplest. In fact, the homework, let's say a homework assignment is for these three, 1, 2, 3, right? I want you to create 3 algorithms in Python, right? Write 3 algorithms following these ideas. So for supervised learning, I'm going to give you this little data set. Write the algorithm that would create that association. You see that? And then from there, you might imagine, okay, I had my understanding of my algorithm. Now I can explore all these algorithms and see how they do it. Okay? Now, what information goes here? A lot of information can go there. That's the beauty of machine learning. I can have one piece of information in here or thousands of pieces of information. And the algorithm learns how to take, whenever it sees all of these different features, it learns to associate with the information on here. Okay? That's the main idea. But in supervised learning, you have this, right? You have this. So for example, let's now come up with a more concrete example. Let's say that I just have 2 classes, right? Something related to the forest or the simplified things or sky. Let's say I have a picture, right? So I have a picture here, and it's a picture of, a boat, right, at sea, and then there's a tree. So if you're building a machine learning algorithm, what do you want it to do? You want the machine learning algorithm to figure out how to process this image, and then maybe it takes that segment and it takes this segment. So this segment is going to be green, right? So then basically you want that to be labeled as, no, it's green. So should be, let's say just say tree. And then this is going to be actually ocean. Tree, ocean, ocean. Right? So now it needs to say this segment is ocean, and this segment here is tree. Those are the labels, right? It needs to say that, tree, tree, ocean, ocean. That's what it predicts. But it predicts that only based on what it sees in the A information, okay? And that's the trick. That's where you have to actually think. And although we won't spend too much time on going from images to features in this course, at least not in the beginning, that's an important, basically, topic, right? An important idea that how do you represent this little segment here? How do you represent this segment into this, let's call it a set of information, of pieces of information. So what do you guys think? How would you represent that? You understand that you're building a model, right? And the model takes in an input, which is A, and produces an output, which is B, right? Predicts the ocean or tree. So what do you think the input could be? How would you represent that? And don't think of doing it like in an algorithm right now, just by hand. Let's say that just by hand, you could look at something and then with a pencil write down some information. What could you possibly do?
You can do true false, so like zeros and ones.
Huh?
Like true false, so you could say green is like 1 if it's true, if it's green,
Okay.
and then 0 if it's false if it's not green.
So basically you're saying you would look at this little square over here and you would say, okay, I look at that, that's blue. So that's a 1, for instance, right? And then
Yes.
you look at the other one with your eyes, you grab your pencil and you say, well, I know that's green, so I'm gonna mark it as a 0, right?
Well, yeah, for that column, correct.
Yeah.
Or row, yeah.
Exactly. And that's basically it. So for A, you have A and B. So for A, you just came up with, so tree, ocean, right? Those are the labels. And over here, the feature, which is just 1, as Josh said, is just a 0 or a 1. So I saw in the first one that it looked green, or sorry, blue. So I called that 1. And then I saw the next one, this one here, and that one looks green. So that's a 0. You just decided that. And then your model learns that whenever it sees 1, it makes it true. Whenever it sees zeros, it makes it not true, tree, and then ocean. And that's the simplest way of doing it. But as you might say, well, that's very little information, just a 0 or a 1. Couldn't I possibly have more? Sure you can. You can have A1 and then you can have A2. And now you can say, well, what other information could I use besides the color? Well, how about smoothness or busyness of the image? Forget about how would a program figure that out? Forget about that. But you as a person, as an intelligent person, you can use your eyes and you can say, I look at this image. So for instance, now let me like, you know, the ocean, you know, in a picture would just look like that, right? So at best, and it would be blue. The image of the tree, you know, which is kind of like that. But, you know, trees are a little bit more, you know, like busy, bushy, you know, kind of like that, right? So you could say which one, and let's call this like busyness of the image. So you could argue that this one is less busy. Let me use another color, actually. You could argue that this is less busy and this is more busy, right? Do you guys agree with that? And let's call this A2. That's another feature that we look at. So now, when let's say that, remember this one, this is sample 1, sample 2. So let's, oops. So sample 2 is the first one, sample 1 is the second one. Okay. So now let's say A2 is this idea of busyness of the image, right? Busyness of the image. So I ask you now, for this one, the first one, S2, right? S2. Where we said busyness is going to be 0 is not very busy, 1 is very busy. So what would be the value here for S2 and what would be the value here for S1? That is to say, which one is 0 and which one is 1?
Wouldn't a tree be 1 and then the ocean be 0?
The ocean would be 0 because it's less busy, right?
Correct.
Then the tree would be 1 because it's more busy. Exactly. Exactly. So let me go ahead and add those values. So the tree is more busy, 1. The ocean is less busy, 0. Do you guys see that? Guys, this is called a feature vector. And the size of it can go from just A1 to ... AN. In almost infinity, right? So you can have 1,000 characteristics that describe this, and the concepts can be color, level of abstraction, you know, doesn't really matter. So now we're defining these feature vectors. And that's what supervised learning is. So we have tree, ocean. Those are the two labels. And now we've said at least, instead of A, let's use the terminology F1, F2. So we're saying this is basically color, and we're saying this is busyness. So how busy is this? Or not busy, let's say contrast or something. Okay, so now one thing that we did is that we made these binary. 1, 1, 0, 0. However, when we were talking about the contrast of the image here, you know, this one was really busy, this one was less busy. Not all trees are alike, right? You can have, yeah, this is the ocean, and this is a tree that's really, can't think of the term for this, but you know, it's busy. It's got a lot of, but there could be a tree that doesn't have that much. You know, it's just kind of like more clean, you know, less. So whereas this one was 0 and this one was 1, this one is what, 0.6? It's somewhere in that scale between 0 and 1. Do you see that? And so my point is that these don't have to be zeros or ones. They could actually be, this could be, you know, let's say we have another sample where the color is green, and so it's a tree, but the busyness is 0.6. So as long, the features are always numbers. They can be binary 0 to 1, or they can be numbers within the scale of 0 to 1, like 0.6. They could be any values, but you usually scale them to a number between 0 and 1. And we'll talk a little bit about that when we talk about the vector space model. So really, as you can see, the values can be numbers, and then the features can go from F1, F2, all the way to Fn. Obviously, so now I ask you the question. Remember the first representation that we had, right? We only had one column, A1. Now we have two columns, right? We have this column here for the busyness, and then this one for the color. Which one of those two columns do you think is best for determining if what you're seeing in the image is a tree or the ocean? Which one of these two is better? F1 or F2? What do you guys think?
Color probably for us.
Which one?
F1.
I can barely hear you.
Sorry, F1. I keep putting my headset up.
Why F1?
Well, what was the F2 on? Contrast, you said, or
Yeah, the busyness of
busyness? Yeah, so I mean, depending on if it's like wavy, or whatever water does, it could be like high contrast or low contrast. Same thing with a tree. Different types of species of trees probably have different.
But you think F1 is better
Yeah, probably.
because usually oceans are blue, trees are
Yeah,
blue, right?
that too. That's another big one. Yeah. I haven't
Exactly.
seen too many blue trees.
You're right, exactly. So one feature, this is probably the best feature. However, this feature might help. You see that? And so that's your job in data science. That's what I want. That's the key thing to understand. And I know it sounds like, you know, very abstract or, you know, crazy, but that's what data science is figuring out the best features to represent your problem. Okay, because they're not given. These features are not given to you. You have to figure them out based on your problem. Okay, and so that's the key concept to understand, that you're learning to associate for a given sample, here we have 3 samples, S1, S2, S3, right? We are learning to associate. We're building a model that you give me, I give you this, you know, I give you this, and then I'm going to predict the label, okay? That's the whole point of this. You're gonna, that's why it's called training and testing, right? So first you're gonna train on some data, then you give it other data that the model has never seen before, and it's going to make a prediction, okay? And that's what supervised learning really is, okay? So that's what supervised learning is. So now let's look at the, so now that we've discussed this, let's go back to these 3 things. We have supervised learning, unsupervised learning, and reinforcement learning. So if supervised learning, so hopefully now you have a better understanding of feature vectors and their associated labels. Right, so you have class here and you have features, right? And then, you know, it could be F1, F2, Fn. So in supervised learning, this is supervised learning. Right, in supervised learning, you actually have the labels. The difference when now you talk about unsupervised learning, is that now you still have the features. Let's say this is, you know, sample 1, sample 2, sample 3. This is sample 1, sample 2, sample 3. But now there are no labels. You see that? That's the only difference, okay, between supervised learning and unsupervised learning. So supervised learning is when you have, you know, some label associated, right? You know, you have a tag. Imagine it's like a name tag, right? It's a name tag. So you have, you know, all these boxes, but the boxes have A tags or B tags associated with them. So that's a good analogy. You have boxes, which are the samples, but you put a sticker, a tag on them that has the information. This is that label, you know, tree or ocean. Whereas over here in unsupervised, you still have the box, the feature vector, but there's no tag. There's no label. So obviously the algorithms, which is, you know, the focus of the course, right? All these algorithms, KNN, neural nets, and so on, ... only work for data that looks like this. But these algorithms do not work for data like this, boxes without tags. So in that case, you have to use unsupervised techniques, of which the algorithm that we will study in this course is called the k-means algorithm. Do you guys see that?
Yes.
All right. Any questions about this concept? All right, the last, and as I said, within this supervised learning, there's hidden Markov models and, you know, recommender systems and all of that. Just think of those as subsets. So I won't talk about those today. But the last thing is reinforcement. So where does reinforcement learning then? And this is the last thing I'll mention today. So where does reinforcement learning fit in? So here, reinforcement learning is actually somewhere between supervised learning and unsupervised. Supervised. It's somewhere between supervised learning and unsupervised learning. So reinforcement learning, kind of somewhere in between that range. So the best way to understand reinforcement learning is with the applications of it. So 2 main applications that you've probably heard about are, you know, in games. right? And also nowadays, like self-driving cars, right? So self-driving cars. So basically, these two are the two main applications of reinforcement learning. So in reinforcement learning, what happens is, I want to put it in the context of features and labels again, because it really comes back to this. So here, you don't have what is called pre-annotated labels. So nobody went, you know, remember that analogy of the box, right? So nobody, in reinforcement learning, you kind of have a box, but the contents of the box are a little bit different, right? So what happens is, you still want to have some kind of a tag, right? So what you do is, you have a game, and think of a self-driving car as a game, right? We've all played like video games of driving cars, so it's kind of the same idea. You know, what is involved in a game? In a game, you have the state of the game, the actions that you can take, and let's just call it outcome for now. It's called, because this outcomes is actually several things: penalties, rewards, etc. But it basically is, given the state of the game, the current state of the game, I take an action, what is the outcome? So it really comes down to like this formula where you have, you know, let's call it step, right, in the game. The step takes the current state plus the action given that state, and it's going to predict an outcome. It's going to predict an outcome, right? That's really what's happening in reinforcement learning. So this really translates kind of into this, where labels here sort of become the outcome. Okay, so labels are now the outcome. But nobody annotated the tag, right? So nobody just went in and gave the box a tag based on looking at the contents of the box maybe. Instead, what happens is, it's like the box itself gives itself a tag because it follows certain rules. The box will say, what is the state? You know, where am I? Where am I? What is the state, right? And then based on that state, what action do I take? Did I win the game? Did I lose the game? Did I, you know? And so the outcomes kind of become that, and then the actions and the state become the features, all right? So in a sense, it's a type of supervised, right? So it kind of mimics that idea of supervised, except that the outcomes depend on the rules of the game. So based on the rules of the game, you have a state and an action. You follow the rules of the game. So I don't know, so the last thing I'll say today, for instance, if you play chess, right? You play chess, right? So in chess, there's basically 64 squares, right? You know, it's 8 by 8. And then you figure out, okay, where, you know, these are the possible moves. This is where I am in the game. So that's the state of the game. Now, given the state, what action do I take? I'm going to move, you know, knight to F3, right? So I'm going to move to a position. So now I take that action. What happens then? Well, you can then evaluate your opponent then moves, you know, knight to, you know, some other position, you know, their knight. And so now you evaluate the game. Which one has the advantage? You know, do you lose a piece, etc. But so that's kind of how reinforcement learning works. But what I want you to understand is, at the end of the day, you end up with something like this, a data set, right, in real time, and you use some additional things in the model to try to optimize for a better solution. Okay, so that's kind of, you know, all I'm going to say about reinforcement learning today. As you Today we've covered basically supervised learning, unsupervised learning, and I sort of introduced reinforcement learning. For now, the best thing is really just to kind of think that reinforcement learning sort of falls within supervised learning, between supervised learning and unsupervised learning. When we get to this topic of RL, it'll become basically, we'll look at the algorithm itself, and so it should become a little bit more clear. Okay. Yep. That should be it. All right. So that's it for today. On Wednesday, sorry. On Wednesday, we will just continue with a few additional ideas. If you have any questions, let me know, and then we'll go from there. All right, so I'll stay for a minute if you have any questions to ask. Otherwise, we'll stop here for today, and I'll see you guys on Wednesday.